Okay, today we will be learning what's called a geometric sequence. A geometric sequence. And let's remember we had a sequence that had a special name. And that was called the arithmetic sequence. What was the arithmetic sequence? So just to recall what we've learned. Arithmetic sequence is basically a sequence like this. So let's say I have 3, 6, 9, 12, etc. And you can see to get the next term, we've added 3 each time. So this is an arithmetic sequence because you're adding the same number each time. And the number that you add is called the common difference. The common difference. Okay, so this was arithmetic sequence. Now geometric sequence is something that's similar. Geometric sequence. Let me write the first few terms of the geometric sequence here. 1, 3, 9, 27. Do you see the pattern here? So how did we get the next term from the previous term? Well, you could say that you've added 2, but here you've added 6. Here you've added 18. So it's kind of hard to see the pattern when you're thinking about addition and subtraction. But if you think about multiplication and division, it's much more simpler. So to get from 1 to 3, you can simply multiply by 3. To get from 3 to 9, you can multiply by 3. And to get from 9 to 27, you can also multiply by 3. So instead of adding the same number each time, for a geometric sequence, we've multiplied the same number each time. And the number that you're multiplying, so 3 in this case, is called the common ratio. Okay, so you can see some parallel relationships between an arithmetic sequence and a geometric sequence. Arithmetic sequence, you're adding the same number each time. You're adding the same number each time, and the number that you add is called the common difference. For a geometric sequence, you're multiplying the same number each time, and the number that you're multiplying is called the common ratio. Okay, so given a geometric sequence, let's see if we can derive a few more characteristics about the geometric sequence. So let's consider a sequence here for 16, actually, just to prevent the numbers from getting too big, for 8, 16, 32, etc. So this is a geometric sequence. What is the common ratio of this geometric sequence? And you can say, okay, how did you get from 4 to 8? And you can say that you've multiplied by 2. And if you look at the other terms as well, you've multiplied by 2 each time to get to the next term. So the general rule for getting the common ratio is to just simply divide one term, let's say 8, by its previous term, which is 4. And then you'll get the common ratio. You can do this with 16, do this 16 and 8. 16 and 8, you'll get the common ratio. You can do this with 32 and 16, in which case you'll also get 2 as the common ratio. So you can try with a few different terms to see if you get the same common ratio, just to make sure that you've gotten the correct answer. And once you've gotten the common ratio, you can now deduce what the next term would be after 32. So what would the term after 32 be? Well, you'll have to multiply each time by the common ratio. So you'll have to multiply this by 2, because 2 is the common ratio, and the next term would then be 64. Okay, so once you know the common ratio, you can deduce the next term. Now, sometimes the common ratio is not as easy to see. So let's consider this example here. 2, -4, 8, -16, etc. And if you just look at the numbers, you can say, okay, we've multiplied by 2 each time. But you can see that there are negative signs in some of these terms. Okay, so what is actually happening is you're not multiplying by 2, you're actually multiplying by -2 each time. And you can see that by finding the common ratio of just choose any 2 consecutive terms, so let's say 8 and -4, and divide the term by its previous term, and you'll see that the common ratio is -2, not 2. Okay, so that's why the sign has been alternating. So if you multiply 2 by -2, you'll get -4. If you multiply -4 by -2, you'll get 8. If you multiply 8 by -2, you'll get 16. So when the common ratio is a negative number, as it is in this case, the signs will alternate. It'll be positive here, it'll be positive here, and then it'll be negative in the next one. It'll be positive here, and then it'll be negative in the next one. And you can deduce that it's going to be positive in the next one. It's actually going to be positive 32. So this is called an alternating sequence because the signs are alternating. When the common ratio, it's not alteration, alternating sequence. When the common ratio is a negative number, the sequence is going to be an alternating sequence. Let's look at another example. Let's say we have an alternating sequence like this. 4, 2, 1, 1/2, 1/4. Okay, what do you think is the common ratio for this sequence? Now this is different from the other sequences that we've looked at because the terms are getting smaller, and you can use the same rule to find the common ratio. So just pick a term, so let's say 1, pick a term, and divide by its previous term, which is 2. And you'll see that the common ratio is 1/2. And you can double check that. Does 4 times 1/2 equal 2? And it does. Does 2 times 1/2 equal 1? It does. Does 1 times 1/2 equal 1/2? It does. So you can check this way. So this example is important because you need to remember to divide the term by its previous term. So divide 1 by 2. Don't flip these around. So don't do the previous term divided by the term. Don't do this term divided by the next term. Okay, so this is not correct. When you're finding the common ratio, it has to be the term at the top and the previous term, not the next term, the previous term in the bottom. Okay, so in this case, the common ratio was 1/2. It was less than 1, and that's why the sequence has been decreasing. It's been going down because you're multiplying by a number that's less than 1. Okay, now you can ask the question that is common for all sequences. Can you actually find a formula to find the nth term? So for example, if I have a sequence like this, 1, 5, 25. can we deduce what will come, let's say, what the 10th term would be? Okay, so let's see this, how this proceeds as we find the next term. So the first term is 1, and the second term is 5. And how did you get to the second term? Oh, before we do that, though, we'll need to note a few things here. The first term is 1, and what's the common ratio? The common ratio, just pick a term, divide by its previous term. So we can do 5 divided by 1, since that's pretty easy. The 5 divided by 1, it's 1, or it's 5. So the common ratio is 5. And to get the next term, obviously, we've done the first term times the common ratio. The common ratio, I'll just write CR here. Common ratio. This is the second term. The third term would then be the second term times the common ratio. So this is the second term. This whole thing is the second term, and you're multiplying that by the common ratio, which is 5. And another way to write this is 1 times 5 squared. Okay, so now this is the third term. To get the fourth term, you'll have to multiply, let me actually draw a table here so that it's easier to see each terms. Okay, so the third term, this is the third term, 1 times 5 squared, and you're multiplying that by the common ratio, which is 5. So you'll eventually get 1 times 5 cubed. This is the fourth term. And now you're starting to see the pattern here. For the first term, we just had 1. For the second term, we had 1 times 5. For the third term, we had 1 times 5 squared. For the fourth term, we had 1 times 5 cubed. Okay, so this number here, let me actually use a different color. This number here is the first term. Okay, so we have the first term. And you're multiplying the first term by the common ratio. Okay, so we're multiplying this by the common ratio. And the common ratio, actually the common ratio is also present in the first term, except the power, we can rewrite the power as 0, because that's just the same thing as 1. And for the second term, the power is 1. Okay, if you look at the power of the common ratio, it is 1 less than the number of terms. So the first term had 0 as the power. The second term had 1 as the power. The third term has 2 as the power. So the power here is actually 1 less than n. So if you want to find the 10th term of this sequence, you'll have to do 1, which is the first term, times the common ratio, which is 5, and then times n minus 1. N is 10, so n minus 1 would be 9. So this would be, or you can simplify this as just 5 to the 9th power. If you're interested in what that is, you can type that in the calculator. 5 to the 9th power would be the 10th term of this sequence. So to get the nth term of the sequence, you can just use this formula. You can use a sub 1 times r to the power of n minus 1, where a sub 1 is the first term, and r is the common ratio. Okay, so this would be, I'll circle in green here, this would be the formula to find the nth term of a geometric sequence.